Welcome to our third Hack 101 of the year. It's on Unity. We had a lot of people, especially Joseph, requesting to have one on Unity. So what we did is we looked around for the person we could find with most experience and best with Unity, and this guy is who we found. He's a really cool guy. I suggest you talk to him. He tried to mate the snake with, I don't know.
Another snake.
That's another story. It was another snake, but I don't know his last name. I don't think any of his friends do either. He is building a game that will be the most fun game you'll never have to play. You should ask him about it. He's a musician in a band. He'll plug that more later. He's all like a well-rounded, amazing human being. And thank you so much for him to come out here. So I present to you Zander Chickenboots.
Thank you. What's up, nerds? So, oh yeah, let me just get this out of the way. I know. Got to give a lecture at 6, but you got to catch them all at 7:30. But I'm Zander von Chickenboots, but today you guys can call me Professor von Chickenboots. Yeah, I've been waiting to say that for a long time. Not really. And this is the first Unity lecture for some of you guys. Boom, look at that shit, that's cool. Okay, by the way, the frame rate is going to suck a little just because we have a very janky system going here. We're screencasting, so my computer's not actually that slow. First of all, I want to ask, prerequisite-wise, how many of you guys have taken Cal 1? Okay, most of you. Cal 2? Okay. Any comp sci, comp 202, something like that? Okay, I'd say like you probably need to know how to code if you're going to do any of this, but if you don't, that's cool because Unity's great in that you can really get away with like a minimal coding, and it does help to inspire you to want to learn how to code better. I got to say, like, I was not the biggest programmer until I started doing Unity, and it kind of gave me a reason to be like, oh, that's why I want to like slog through all that documentation and APIs, because I can do cool ass shit. So, without further ado, everyone got Unity loaded up, by the way, and ready? Because you can follow along if you want, but I'm really just explaining like theory here, so it'll be a bit before we get into like the you try this right now. So, okay, I was gonna say, oh yeah, okay. So I've got some unofficial rules of game dev. The first rule of game development for me personally is get a mouse. If you're using trackpads the whole time, you're gonna have a bad time. Rule number 2 of game development is you do not talk about game development. Rule number 3, I don't think I had 3 rules, that was it. It's probably also don't talk about game development. Anyway, I'm gonna start off with this super duper simple scene and just like, I don't know how many of you guys have any Unity experience versus like 0, but I'm just gonna go ahead and assume 0 for now. Let's get rid of that. So, if you guys have ever tried to code in something like Eclipse and make like a pure Java project, it's hard, but it's very fulfilling. Unity is great in that all your most basic elements are pre-built. So you get to work in a 3D space. And keep in mind that even when you're doing 2D in Unity, you are working in a 3D space, but you're just pretty much never using the z-axis except for overlays. But all collision happens in a single plane. So, I don't know if you can see my mouse, yeah. So this area right here, Unity's cool because you can kind of just take all these things and pop them wherever you want. I have a kind of workflow, or this is how my thing almost always looks. When I have a second monitor, I'll pop out my game tab over here into another monitor, but for the time being, that's fine. So the basic elements is you got your little bar up here, not the most useful thing for the most part. You got your little transform tools here. These will change the way that you manipulate objects in the 3D space, but we use hotkeys for those. These pivot and global, those are important, but I'm going to get back to those later. So the big old box right here is called the scene view, and this is basically God mode in your game. This is where you get to look around and just kind of go wherever and look at all the objects you got. Right now I don't have much. Let's see, where's my, here we go. Over here is the inspector, and when you click on any object in the hierarchy or in the scene view itself, you get to inspect its properties. Whoa, who would have thought? Down here is the project, which is basically just the file explorer. So you can go through all your stuff. I think the root folder is always assets, but I populated mine pretty heavily, and I suggest you guys do the same. I was going to try to work with a blank everything to start off, but it's really not worth it. But the first thing I usually do is start making folders, because assets start to pile up very quickly and you're going to want to know exactly where they are. So my default folders are scripts, 3D models if you're using those, scenes, because you're always starting with the scene, and maybe textures and materials, but again, that's a little bit later and you can just browse the hierarchy here. The hierarchy itself will show you all the objects that exist in your current scene. And when they say scene view, it's called the scene view really because in Unity you kind of have this like discrete separation of levels or scenes, and all that really is a single scene will contain a starting state for a game. Let's say you got like a dungeon level, right? And your player enters the door to the dungeon level, that will load a new scene. And you can already have the whole dungeon meshes set up, all the collisions and the nav mesh set up so that when they load that scene, everything is exactly the way you want it to start. And from there, it can evolve and change as you will. But you basically be wanting to package all your gameplay, levels into these scenes. So off the bat, I don't know how many people have it open and just have blank everything. If you try to hit save right now, it'll ask you, where do you want to save this scene? And that's because whenever you hit Control S, which you should, by the way, be spamming every time you do anything important, because who knows? No auto backup on here. It will ask you to provide a folder location for where to save that scene. So if you want to try that out, just go ahead, Command or Control S, whatever Mac, PC, and then make a scenes folder and pop this scene into it. Call it whatever you want, like test, default, start, whatever. Doesn't really matter. But that's another reason why the first thing I do when I open a blank project is just start making a bunch of folders. Okay, so I covered the inspector window over here, very important. These are all the most basic windows besides the game window, which shows you what the end result player would see when they're playing the game. And notice how you can see in the game view, I'm in the game view here, we've got our little sphere and our little cube like at a certain position, but in scene, they can be all over the place. And this does not affect, like I can move them completely the other way, this does not affect the game view. What is rendered to the game view window is dependent entirely on the main camera. So I cannot, I'm sure there's a pathological example, but I cannot think of a single instance where you would not have a camera in a scene. You pretty much need that crap. At least one. You can have multiple, but honestly one is mostly what you'll need. So this main camera's viewport, you can see it kind of like stretches out all the way here, and this shows you it's like an infinite perspective view. So this is also dependent entirely on the size of this game window. So notice if I pop out my game window, you see it's so big and rectangular, we can see the camera is super wide. Now if I go over here and just shrink that down a bunch, that will correspond to changes in the viewport's kind of wireframe box over here. So it's an important thing to keep in mind because you might have UI and stuff that will get cut off when you resize your game window while you're making the game. In reality, the screen that you're building for might be a very specific aspect ratio. So really don't worry about that off the bat, but until you're making UI and stuff. But you should always be keeping that in mind, that like don't worry if it doesn't quite look right in the game window because you will be able to control that fully later on. Just focus on getting it to work first. So here we go. The most basic kind of element in Unity is called a game object. So you can create an empty one. It's basically just like a container for all the fun stuff to live inside. For instance, this camera is just a game object with a camera component attached and all these other components over here, as is every single other game object. So now you can make any game object, usually empties from this little menu up here, or you can hit Control-Shift-N, as it says, to just create an empty one. You can also make primitives, which are useful to do quickly when you're just mocking stuff up or you just need a box or something. You can do that through here and stuff. So I just went ahead and made an empty game object to show you like the basic idea of what it is. So since Unity is natively in 3D, all the game objects, no matter like how stark, this one's completely blank, they have to have what's called a transform component. Now this means like every object you make and place into a scene in Unity will be aware of its position in space, even if you completely don't care about it. And that's not a problem at all. It's actually going to be useful because a lot of the times you'll have scripts that are like a level manager that will handle like probability of spawns of certain things or just controls the weather, and it really doesn't matter where it's placed. But also keep in mind that every game object does have a transform. A transform holds its Euclidean position in space, so x, y, z axes, and you can move them around with these little arrows. Red corresponds to x, blue corresponds to z, and green corresponds to y. So Unity is a z forward system, which is the opposite of, I think, Unreal and definitely Blender, a 3D modeling thing. A lot of those guys use z as up, which I tend to prefer actually, but in this it's y is up. So that's definitely important to keep in mind. So whenever you click on any game object, empty or not, it's going to show this little thing by default. Now back to these little buttons up here, transforms also have a rotation. So if I go ahead and hit this little guy, it pulls up this little orb type deal. And this will now allow me to rotate the object at will. And I can use this to be like, oh, only rotate in the x-axis. Green, only rotate in the y-axis. Z, blah, 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 you get the picture. So that's another, it's called a transform handles, basically. Now you have this guy, which is for scaling. You see that every transform also has this scale component, which is default 1, 1, 1. So now I could scale my object using these little handles. Honestly, I almost never use the scaling handles because not a lot of the time do you have the freedom to just kind of be like, oh, let's just make this guy really wide or a little bit less. I'm always entering my things in manually. So I usually just tab across, 0 everything to start if it's not zeroed. But that is pretty much the atom of Unity. It's this game object type thing. So instead of using these little buttons over here, which gets annoying really quick, I use W, which is this default position handles, E, which is the rotation handles, and R is the scale ones, again, not used so much. And while you're in the scene view, I don't know how many of you guys have mice, but middle mouse button is pan, so you can drag around and kind of reorient yourself. If you hold down Alt and then left click, that's orbit around your focused object. And then I think I can go, what is it? Yeah, if you just right click, it's kind of first person look around. So you can expect your thing from a fixed position and orbit, the kind of your current camera's position. Another very useful little hotkey is if you've got if you're zoomed out like crazy, right? And you have nothing clicked and you're like, crap, I can't see anything, but I want this empty game object that I see in my hierarchy, and I want to focus on it, you can hit F, and Unity will zoom into that object. It helps if this thing isn't naturally invisible, but for instance, this guy, it gets small real quick, so I can just hit F, and boom, there it is. If you hit F twice, you will now track that object, so as you move it, you'll see the camera moves along with it. So that's very useful when you're kind of trying to follow a car that you built. You want to make sure it explodes correctly or whatnot. Okay, so that's the basic empty game object with nothing interesting on it. So now I'm going to talk about this parent-child relationship, which is how you build interesting things using this game object type deal. So I went ahead and made a default sphere, which you can go game object, 3D object, sphere, or whatever shape you want. It's really irrelevant. Or you can make an empty object, which I think is good to show. I'll take this empty game object I made before, and I can just build the same thing that Unity will put in from scratch. It's important to know that we work through this component type deal. So a transform is a component. Everything that you see on the inspector will be a component. So I can go ahead and go add component, and then you can search through all of the assets and components that are built in and available. And I can go mesh filter. Mesh filter provides the renderer a link to which mesh you actually want to use. Next, I'm going to add mesh render, which actually renders the mesh that we're going to provide. And we could add a collider, which is default added when you add these primitives, but we don't need a collider right now. So I'm just going to go ahead and go right here in the mesh. What I could do is I could go to 3D models, or Unity has default things stored in, and I can just drag in this mesh. Oh wait, I have to grab its actual mesh. I can pop that in there, and now it has a shape, and it's rendering nothing because it does not have a material. So unless you explicitly wanted your thing to be bright fuchsia, that usually means you forgot to put a material on it. So keep that in mind. Another way you can do this and pretty much search for anything without having to click and drag, if you can see this tiny little circle over here, that's the search feature. That pops open this thing, and then you can select through assets or scenes. Scene means it'll only search for stuff that exists, as I said, within this current scenes hierarchy. Assets search everything you have on disk. So I'm going to go ahead and just search sphere, and this is the Unity default one. And material, we're going to search, and I'm just going to go default. I think we got something here, and boom, we just made the sphere from scratch, which is good to know. So I'm going to go back to the other guy I created, this sphere. So now Unity is based on a parent-child relationship, or in that anytime you have a game object, all of its transform data, like its position, its rotation, and its scale, are set relative to its parent. Now, when you look in the hierarchy, if it is not under anything besides, being ordered under it, but you see this child object is literally inset under it, and it's got this little arrow. That tells you that this is a child of the parent object. And that means all its transform data is relative to its parents. So you see my parent object here, it has, here, let's just zero that out. And now I added a child object, and you can do this just by simply, here, let's start from scratch over here. Got this guy. You can see that it has its own information, and since it's no longer a child, it's just in space, and all of its data is relative to the world. So there is a distinction called world space versus local space, which becomes mind-boggling when you start scripting and realizing, like, oh my god, I actually have to need to know that. So it's good to know from the start. Its X position here is, of course, relative to the global world origin, 0, 0 here. And so is its parent object. Now I'm going to go ahead and just move this guy. Another quick tip, if you click anywhere in this little box here, you can kind of free move this guy. Also not super useful, since you should probably know exactly where something should go. But I'm just going to drag that over here because I'm the prof and I can do what I want. And child object, we can just drag it, and you can reorder the things in the hierarchy if you want. It's useful occasionally. And if I just hover over parent object here, you can see it highlights, and I'm going to click, let go, and now child object is the child of parent object. Look at that. So now you're like, well, what the hell's the point? Notice that our parent object's transform is zeroed out, and this guy is 1.5, 2.95 because it's over here. But notice these values change when I unparent it. Oh wait, I guess not, because it's relative to 0 anyway, right? But now I can move this child independently by clicking on it, selecting it, and moving it. But when I move the parent object, the child object moves along with it. And that's, of course, because this guy is no longer 0. I'm just going to move this somewhere else. You can see that this child's object's transform can be 0, 0, 0, and still not be at the origin. And this is because all of this data is relative to this guy over here. So you can build quite complex stuff just using this parent-child relationship. Like, for instance, when you do animation and stuff, when you're building these complex like figures, you use bones, which, whether you're using Blender or Maya or whatever, and Unity, is the same parent-child relationship. When you think about an arm, let's just consider the arm being parented to the rest of my body. This is like the root joint right here. Its position is completely dependent on the rest of my body, right? But now my forearm would be parented to my upper arm, and my hand would be parented to this. So you can see this whole hierarchy kind of folding up. The tip of my finger is parented to this guy, which is parented to this guy, which is parented to this guy. So that means I move my hand, I don't have to worry about the fingers go where they go. I move this part, it moves the rest of its children, et cetera, et cetera, et cetera. So it's important to really have a good grasp of this parent-child thing, because all of the complex behavior comes from having a nice system, which all has one game object parent and like tons of siblings and children. A sibling, by the way, we do it by levels. So if I go ahead and duplicate this child object here, its parent is obviously parent. This other child is over here. Since it's on the same hierarchy level as this other child object, they're both directly descended from parent. They are siblings. And now I can go ahead and make another one and make this a subchild of this guy. You can see I can move it independently when I'm selecting that. If I move this, it moves, and I move the whole thing. They all move. Okay. Enough of that. Okay. Oh yeah, also complex mechanical systems, which you can do in Unity quite easy because they provide with all these joints. Always parent-child, you have to be very aware of exactly whose parent is what and what the best way to approach it is. Like I said with the arm, like you don't want to parent the hand to a finger. It's not going to work. So back to the inspector part. So you're wondering like, well, where's the code go? I can add component and just go script. All code in Unity is referenced to as scripts, since when you think of pure Java code or C code or C++, whatever, it's not necessarily a script because they can interact dynamically, without a loop. Like you can execute code and just have it wait for your input. Unity calls it scripts more like because once you hit play in Unity, things are going to behave according to their scripted behaviors. So when we go add component, every single thing you see here, this mesh filter, this mesh render, this material slot, the transform, they're all known as components. So all the meaningful functionality that is imbued onto a game object comes from its components. So we could go add component, and if I just clear this little search thing, you can just browse all the different components that are available to you. Now depending, you might have some add-ons or some packages that you've downloaded, so you might see more or less in here. But for the most part, you'll always get mesh, physics, physics 2D, audio, rendering, layout, blah, blah, blah. So if we wanted to add collision and stuff, it's all under the physics thing, and it's very easy to just go ahead and search. Let's say I want to put a sphere collider right here. Boom. So you'll see when you click on any object, you're going to get its little kind of blue outline, which is its mesh. So over here we have this green outline, which represents its collider. So collision is very important for a ridiculous number of reasons. I'm sure you guys can figure it out. But the colliders are always going to be in green. So I can go ahead over here and add a box collider to stay consistent. And you can see that's in green. And I can actually turn off its mesh renderer, which prevents it from physically being seen. But you can still see its collider, because its collider is visible. Another thing to note is that when you minimize any of these things in the inspector, the gizmo, it's called for that, like the scene view representation, will go away. So that's useful when you just don't want to see that crap all the time. But you can see this guy has its green collider over there. Unity provides you with a bunch of different, it's called primitive objects. You can see you get the cube, sphere, capsule, cylinder, plane, and a quad. And most of these have unique colliders. Like a cube has a box collider. A sphere has a sphere collider. A capsule has a capsule collider, which basically is two spheres connected by a cylinder. But there is no cylinder collider. A cylinder actually will just use a capsule collider for performance reasons. And then you have just a plane, which is interesting to note because a plane does not have a plane collider. It has what's called a mesh collider. Now you're thinking like, well, that's all well and good. I can have my box collider. What if I want to be colliding with very complex shapes, like a custom 3D model battle axe or a spaceship or something? That's what the mesh collider is for. I can go ahead and take like any complicated object. I don't know if I have any complicated objects to show you. I don't think I imported them, but basically you can take any mesh you want, and just by adding the component mesh collider, it'll generate a collision mesh for you that will perfectly fit your guy. Now the problem with this is that mesh colliders are extremely expensive in terms of performance because, when you're trying to collide two boxes, how many vertices you have to worry about? Not very many. When you have a super detailed high poly alien mesh with a mesh collider on it, you're going to be checking collisions against like thousands and thousands of vertices, which is going to kill your CPU. So for the most part, in almost every game I've ever made, I only use mesh colliders for very specialized circumstances. And you can really get away with using what's called compound colliders. And that's like, let's say I'm going to approximate, I'm just going to get rid of this. I'm going to approximate some like humanoid figure here with primitive objects. So let's see, there's a sphere, it's your head right there. I'm going to go, you can right click on an object and then also go create all those same things to just instantly make it a child of that. Let's get a capsule, it's your little torso right here. And like blah, blah, I don't know, cylinder for your arm here. Oops. Boom. So now, instead of having a mesh collider for this guy, I can literally just use a sphere collider on the head, a capsule collider over here, and capsule colliders for the arms. And it's called a compound collider because the parent of all of these objects will actually treat all its children's colliders as its own collider as well. So if you have any scripts that are recognizing collisions, you want to put it on the uppermost game object in the hierarchy, and it will actually automatically go, if I register a collision on one of my children, I'm going to count that as me registering a collision. So you don't need to have collision, reactive scripts on every single limb this guy has. You can all have it on the parent, and it will treat those collisions as if it were its own. That's a very useful thing to note. Where am I going with this? Okay, colliders in general. I should give you a talk on this. So sometimes you got a game object and you got a collider on it, but you don't necessarily want that collider to be exactly the same shape or size. Like for instance, if I have this box, it's like it's an item, right? I don't want to have the player literally collide with the box itself. I want some like larger area over, he gets close enough to it and boom. So if I edit the scale over here, you see the collider scales smoothly with the scale of the object itself. So if I want to keep that scale at 1, I can go to this box collider over here, and you see it has size. I can actually manipulate the size of the collider independently of the size of the thing. And this gives us a nice little thing. So now you can be very creative with this and come up with some very cool functionality just by messing with the collider size. So you can either input it manually. You can also change the center, so you can really have it wherever you want. But a much more intuitive way to do this is you can go to Edit Collider, which is right over here. I can click on that, and it gives me these little face select handles over here that I can just freely manipulate. And it automatically calculates recentering and resizing as you do it. Just be careful, because if you miss clicking on it, you have to be very finicky about where you click on it. So do it as close to the little dot as possible. And you can freely edit that, so that's nice. Again, I missed. It's annoying. Unity, patch that shit. So, colliders, it's a topic it seems very simple, but it's actually, there's a lot of subtlety to it. As I said, mesh colliders are expensive. They have a convex feature, which basically cuts its poly count by taking a convex hull, whatever mesh you have. So I would check that if at all possible. / just don't even use mesh colliders unless you really, really need to. But we're going to the same exact logic applies to mesh colliders as everything else. So let's grab, let's go this cube. So you see it's got this other thing right here that says is trigger. So colliders recognize collisions under varying circumstances. For instance, this guy right here, it has just a collider on it. So if I were to put a script on it and say, okay, when you collide with something, like hit me up, and it will most likely not ever say anything to you unless you have another object that comes and hits it with a rigid body on it, it's called. So this is now getting into physics. Trigger, what a trigger does is it makes it that, so if another object hits it, it won't act like that object has a collider at all. It's literally just a trigger. It'll pass right through it, but that any script attached to this object with the trigger on it will be able to go, when I am entered as a trigger, do something. So I'm going to switch scenes right here to the physics bit. Let's open a new scene here. I know if it's going to say play mode. Okay. So this is the little physics demo I made. Just a bunch of crap happening. And you can see we have real physics. I want you to know that there is, oh, wow, it's real slow. Whatever. I want you to note that I didn't write a single script. None of this behavior is coded on my part. This is entirely handled by Unity. And it's amazing that you can get this kind of awesome behavior without writing a single line of code. So let's take a look here. As I said before, there's lots of different ways to combine colliders with other components and get various behavior. As I said before, this is just a stock cube with a box collider and no rigid body. I'll get into rigid body, the details in a sec. So you'll see that this guy over here is registering collisions with it. But this cube itself is just floating in space. It's like, I don't give a fuck about anything else. I'm just going to basically be an infinite mass, unmovable object. I'm here, all y'all can deal with me, and everyone else has to worry about it. It doesn't have to actually do anything. So that's very useful. Now notice this trigger thing, when I click it, boom, our little ball goes right through it. Now, if I had a script on this cube, it would be able to tell that this guy is passing through it, but the ball itself acts like nothing is there at all. And also, it will no longer register collisions with a trigger. So, let's pause here. By the way, you can hit Control P to play instantly and Control Shift P to pause while you're playing, which is, seems like whatever, just hit the button, but trust me, there are circumstances when you're like, I don't have enough hands. So I'll just unpause that. Now this bouncy ball that we had before, it has a collider and a rigid body. Rigid body is what allows a Unity game object to actually react to physics in a semi-realistic manner. As you saw before, this little box dude over here, it didn't have a rigid body, it doesn't care. This guy now is suddenly like, whoa, swagger, it works. It has also a collider, which is not a trigger because it needs to register collisions. But what the rigid body does is it imbues mass, drag, and gravity, all these things, to this game object. So you can now specify the mass, and Unity is very cool in that all of its units are actually the standard scientific units. So if you have a mass of 1 and you apply a force of 1, it will accelerate to 1 meter per second, or 1 Unity unit per second. So all that force is in those kind of metric-ish units, but it's all unitless, of course. So we have our mass thing, we can change it. You can see when I hover over, which is very useful if you don't know what certain things are, it'll tell you as much information as it can on it. For instance, mass cannot be 0. It can be super duper small. I think that's floating point precision minimum, all the way up to a ridiculous amount. You have drag, which if we hit play again, you can see it's bouncing up and down. Now, if I increase its drag, look at that, it stopped. Angular drag is, of course, the same thing, but for it rotating. Use gravity, okay, it makes it use gravity. For instance, if I let this ride, and then check this off, boom, Rocket Man. I just did that double F thing to follow it. Can you see that? Oh, there you go. Didn't realize, yeah, stop me if I'm like, can you see this with my mouse? And nothing's happening because I'm not looking at that thing. Is kinematic. This is another subtle but important thing. When we just have our default sphere bouncing up and down, I have gravity check, right? Yeah, it does its thing. It reacts to physics. If something else hits it, it'll collide and bounce off appropriately. Is kinematic basically removes all of the nice features that the rigid body itself imbues. I can uncheck and check use gravity, it doesn't care. I can make the mass and drag whatever I want. As long as is kinematic is checked, none of that's going to apply. What is kinematic does is it says, I want other objects to react to this object as if it were a regular rigid body reacting to physics, but I don't want this object itself to react to other physics collisions. Basically, you do this when you want to drive all of this object's actions and motions by script. And you may be like, well, why don't I just not have a rigid body at all? It's a little complicated, but basically, a rigid body is needed for this object itself to register collisions, and it helps a lot for other objects to register collisions correctly and deal with its mass and all that correctly. But that's what is kinematic does. It basically says, I don't want this guy to live as if it is a physical object. I want to drive it purely through position manipulation. So whereas this guy just goes, oh, I react to gravity, I move down because of physics, you would then, if it's kinematic, you'd say, I would alter its position frame by frame in a smooth way to approximate that. Don't worry about the interpolates stuff really too much. It's not too important. Collision detection, this is just how often it's going to update and check for collision. So discrete means it's going to happen at a lower rate. Continuous, faster, and continuous dynamic means that it doesn't go to sleep, which is not really too important to know. But basically keep in mind that discrete is fast, continuous is slow, continuous dynamic is hella slow. And the only real situations where it's useful to actually choose continuous or continuous dynamic is when you have very fast-moving objects which are physics-driven. For example, if I was doing bullets from a gun, and instead of just checking if something's in front of me, which is a common technique, if you actually want to launch a bullet using force, it could be moving extremely fast to the point where it's at position A at time t = 0. There's an object over here. And then its speed is so high that its next update frame, it just teleports over here. And this object in the middle will never know that it got hit because it was never actually in that position. But if you check continuous or continuous dynamic, it's going to be a lot, even if it doesn't necessarily exist in that position, it's going to pull for collisions on that way. So that's useful for very high energy stuff, very fast moving things where you might miss a collision. That's where I would use this. But for the most part, discrete is totally fine. Let's see here, constraints. Constraints is an extremely useful thing too. So kinematic is functionally equivalent to checking all the constraints on this thing. Constraints mean that we're going to independently freeze the position in the x-axis versus independently freeze the position in the y-axis or independently freeze in the z or rotation over here. Kinematic is the equivalent of basically checking all of these at the same time. So this is not the best guy to be picking. I'll pick one of these dudes. So you see this guy's bouncing all over the place. It's got a rigid body. Let's say I want to freeze position in the x. Notice it's not moving in this x-axis at all because I just froze it. But it's still reacting to physics like it should. You could freeze it in the y too. It would still react to physics in the z-plane, as it is doing, because it's left unchecked, and rotation, obviously, it freezes its local rotation around that point. But that's very useful when you, for example, have a character, right? That's like a capsule-type shape. He's going to be walking around, and maybe you want a rigid body just because a lot of the times it is easier to move things with physics because you don't have to necessarily constantly tell it where to be exactly. You can just be like, add force forward, and then if any other forces hit you, you'll react correctly. But you want to add force to this character in its local forward position this way, but it may just tip over and fall because it's a big capsule shape. So that's another instance where it'd be very useful to just check, okay, don't rotate in this axis. Or don't move up and down. If it's like a car game and you're just going left and right, then there's no need to have force there. So performance-wise, it's negligible, but there is a tiny benefit to just Xing out some of the possible degrees of freedom it has. It will then allow it to be like, okay, I don't need to check for there, so that's one less little function call I got to do. Okay, that pretty much covers rigid bodies. It is a confusing subject, so I do want to ask if anybody has any questions about how that works and the dynamics with colliders and stuff. So anybody confused? Okay. Trust me, you're gonna be Googling the crap out of this soon. But another useful thing that I should mention is that Unity does have a table which tells you what kind of things will collide with other types of things. You're like, okay, well, shit with colliders will collide. No, it's very confusing. You can have kinematic rigid bodies with trigger colliders causing collisions with non-kinematic rigid bodies without trigger colliders, or all this kind of crap, and you're like, whoa. Sometimes it's very useful to know, will it collide? So just Google that and check that collision table because it is useful to know. And sometimes you can actually use that collision table to be like, all right, I want a certain dynamic. How can I set that up so I don't get collisions between these types of things, but I do get collisions between these types of things, blah, blah, blah. So that's a good thing to keep in mind. It's a lot subtler than you might think off the bat. So, what else do I have here? Did I skip physics? Oh, I guess so. Now, I will show you this cool thing called physics materials. For instance, why is this little sphere dude bouncing up and down. And it's because I have created something called a physics material, which you can see here. It says bouncy. And this is a cool thing because every collider will have a physics material slot, and it doesn't need a physics material slot. For instance, I can just click on that and just hit backspace, and it'll just get rid of it. And now you see this guy, which was bouncing before over here, is just kind of rolling around because it has a the most basic physics material, which is none. It just has no friction, it has no elasticity, etc. So if I examine this little bouncy physics material I have, every time you create a new physics material, it'll ask you for these parameters. So dynamic friction, I don't know if you guys have taken Phys 141, 140, something like that. But that's, of course, the friction applied when the object is already in contact with another object. Static friction is the friction that applies before this object starts moving. Bounciness is between 0 and 1, 1 being maximum bouncy, 0 being 0 bouncy. And then you have the way that two objects with physics materials will interact with each other, which is interesting because friction combine, you can go, I'll take the average of my physics materials friction level and the guy that I'm colliding with, I'll take his friction level and then average those out. Or I can do the minimum, multiply them, or the maximum, bounce combine, same exact thing. I'm pulling the maximum here because I just wanted the maximum bouncy. But you can create everything from like wood, rubber, ice, greased ice, anything. Like it's amazing that you can really like just play around with these things and you'll get convincing results. Like I had a bowling alley level one time where the material, I just had no material on it. I was like, whatever, I don't really need it. And I started playing around with adding a little bit of like iciness to it, just like a little less friction to make it slide like a wax thing. And then make it like not so hard, just add a little bit of bounce so it's not like solid steel, but it's more like wood, which has a little bit of give to it. And it created such a more convincing like bowling ball hitting the thing. You can see the bowling ball like kind of skids, but also adds torque. And it also doesn't just clack into it and bounce off like they're both ceramic. It does have this little bit of give to it and bounce. And it's like, you can really get subtle but very convincing effects just by manipulating these. And to create a physics material, you can just right click anywhere in this little project area here and go create, and this gives you all the various things you can create. So right here we have physic material, they call it physic. And you got physics 2D. And of course I'm doing this whole lecture in 3D by the way, because 2D is, doing a 2D game is exactly the same as a 3D game, but instead you have to write 2D after everything. So don't worry about that. All the colliders, there's a square collider instead of a box collider. There's a circle collider instead of a sphere collider, etc. So it's much better to learn in 3D and then reduce down to 2D than to do it the other way around. So you just click on Create New Physics Material, ask you to name it. We'll call this Ice. And we'll just set dynamic friction to 0. Static friction to 0. Bounciness, I don't know, let's give it a small value because ice has that. And friction combined, like, well, let's say this ice is so icy that it doesn't matter if the other thing's made of like tar, it'll be the minimum, which is in our case will be 0. Bounce combined, I don't care about that. So I'm going to go ahead and take this, the plane that we're working on here, I'm just going to drag this ice over here into this guy's physics material. And I guess I need a little box or something to push around on it. Cube, over here. So we're going to zero it out. A very quick way to zero it is just to click over here, hit 0, tab, 0, tab, 0. And you can just keep hitting tab and zero out everything. It's very quick. So I'm going to put this guy over here. Let me see if you can see it in the camera view. Yeah. And I'm going to give it a material just so you guys know that it's different. Oh, not that material. I don't know, something like this. I don't know, it's not very useful, is it? Yeah, there we go. Fuchsia. Oh, why isn't it fuchsia? Whatever. Anyway, this is the guy who's going to be all icy. So, this guy, as I said, he's going to be all icy, but the floor is really the one who's icy. So anyone who reacts with the floor is going to experience the floor as if it is ice. So I'm going to add a rigid body because I need it to fall, hit, and then be able to be moved around my physics. I'm not about to script this. And I'm going to add something called a constant force, which basically when it's active, it applies a constant force. So just a quick aside, because I wasn't planning on really going into detail on this, it's fairly obvious. Force, you specify a force vector. Of course, knowing like any vector algebra and manipulation is like paramount to Unity dev, because it's all positions, all rotations, they're all in terms of vectors. So you should know your vector addition and multiplication at least. Yeah, so this is your global force vector. And as I was saying before with local and global, this means that if I say 5 in the x, every single frame it's going to apply a force of 5 in the global x-axis. And you can see the global x-axis is always dictated by this little guy in the corner and these little transform handles, as long as we have this global thing ticked here. Now, relative force means with respect to its local rotation. So as before, if we had my little cube guy parented to my sphere, and the cube is all rotated in reference to that, its local x-axis is not going to necessarily be the same as the global one. So by using this relative force area over here, you're specifying, I want it to be relative to my transform's orientation with respect to whatever parents we have. So now I'll just show you about this, this little global tag over here. Since this is, that doesn't have a parent, it doesn't need a parent for this to be important, I'm going to go ahead and switch to the rotation thing. I'm just going to rotate it some like randomly, right? And now if I notice, I go back to the transform thing, even though it's all rotated randomly, its little axes over here are still relative to the world. I can check this, it just toggles between local and global. Local shows us, given its original orientation, where is its up now in the world space. And switching between these like handle orientations are useful when you're trying to arrange stuff, right? So say I want to duplicate this cube and just like keep going and have it go that way. If I was in the global view, it'd be very hard to get it to go exactly, along this face. So they're all parallel and stuff. So that's a good thing to note. But that's not the point. The point is this constant force. And let's just zero out its rotation real quick. So I'm just going to add a constant force to show you how it slides along the ice. So we got 5 in the x. Let's just give it a little room to play. And let it play. And it's going to fall. And look at it. It's sliding. And that's because it's icy as hell. Now, if I go back to our floor and say, okay, you have no physics material, you're going to see it's got a lot more resistance when it hits the thing. In fact, yeah, it's not moving at all, even though it still has this constant force on it. I can actually crank that force during runtime, and apparently its static friction is a lot, but look at it. It takes a lot of force. I had to go up to that 15 before it even budged, whereas if I had the ice on it, it moved instantly. So again, go crazy with your physics materials. There's a lot built in, but honestly, like the most essential ones is rubber, ice, and basically nothing at all, like metal or something, which you can make very quickly, as I just showed you. Just bouncy, max out the bounce, ice, minimize friction. Maybe you want to deal with the friction combine and stuff, but that's up to you. So that's physics material or physic material for you. Now another extremely cool Unity feature that we have that I'm demonstrating here, let me just clean up a little, is joints.
Quick question.
Yeah.
What's the maximum force you can apply?
Oh, like, what's the maximum value for a floating point?
Okay.
I think it's like 2.
You can't apply like infinite force or anything, can you?
You could, but it's like kind of meaningless, because if you, like, let's say Unity allowed you to apply an infinite force,
Yeah.
and your thing is over here, in one frame it would be infinitely far away.
Right, but if that object was an immovable one,
Then you're doing nothing, then it won't move. I see, philosopher. All right. What happens when you apply an infinite force to an unmovable
yeah, I'm
object?
curious.
Well, in Unity, literally, let's go ahead and do that. Let's answer this age-old philosophy question using Unity 3D. Woo! Take that, Philosophy 101. The short answer is it just won't move.
So the object wins.
Yeah,
Take that, philosopher.
exactly. So here we just added constant force, a rigid body. Now we'll just set its kinematicness to true, so it's not going to move. And I don't really know how to input. I think I can just go inf. Yeah, there you go. You can just type inf in the box. It now has an infinite force to the right. And I've never actually tried this, but I'm pretty sure it just won't move. Oh, look at that. We got an error. Wow.
Damn it.
Force assign attempt for sphere is not valid. Input force is infinity. I guess the problem persists. Interesting. I wonder if it's not kinematic. Will that make a difference? Yeah, still doesn't like it. All right, I guess you just cannot apply infinite forces. Look at that. Good question, though. Joints, right, like I was talking about. Not the Bob Marley kind, but the mechanical engineering type. So, joints are another subtle thing because in reality, joints, when you connect two things with a joint, both of those things are involved and aware of the joint. In Unity, when you have a joint, only one object needs to be aware of the joint to the other object. So for instance here, I've got, I forget which one holds the joint. Yeah, this sphere guy right here, it has a rigid body, a collider, blah, blah, all that, but no joint on it. Or maybe it does. Actually, I'm multi-editing. Yeah, no joint. This guy it's connected to via this invisible joint has something called a fixed joint. Now, this will react the same as if I put another fixed joint on this guy and said connect to this dude, and then remove this guy. Or if they both had fixed joints, you really only need one. That's the thing. So what this fixed joint is, you have all sorts of different types of joints, but fixed joint is the simplest. Basically, it's a hard, immovable connection between these two things. So when you add a joint to something, any joint requires a rigid body. So if you don't have a rigid body on it in the first place, it'll actually add one for you, which is useful just as a speedy trick. But once you add it, it'll go, okay, connected body. That means what am I connected to? And it needs to be in the form of a rigid body. You can see that it has rigid body in parentheses, which is the type. So you need to provide it with something else. So in this, I just added a fixed joint and I said, okay, I had this guy over here. You're now fixed to this dude. So it's important to note that that joint's kind of behavior, as soon as you hit play, whatever spatial difference exists between the two as you hit play, that is the length of the joint, that's the positioning of the joint, that's all of the things. So for instance, if I just clean this up and go, what are you right here? So you're 0, you're, let's say 5, and you're 2. And I'm just going to put it exactly on a line, some number of units away from it, and you can see the difference. I'll just go 0, but what did I have? 2? No. Oops. 5, right? 0, 5, 2. So now they're in the same place. Another useful side note is that whenever you're rotating or moving these guys around with the little transform handles, if you hold down Control, or I think Command on Mac, I'm not too certain about that, it'll snap to integer amounts, which is very useful for rotating things 90 degrees very quickly without typing in 90. So I'm just going to move this guy over some number of units. So now, when I hit play, the length of the joint right here is defined as its current settings. So we go ahead and hit play, and you see that, boom, they're connected that way. It's a little hard to tell because they're moving exactly the same. But now if I move this guy up some units, the length of the joint just increased. I go boom, and you can see that, boom. That's a pretty boring joint, but it does have what's called break force and break torque, which is the force required to destroy that joint. And look at that, it's at infinity. But yeah, you can set these to any sorts of values. For instance, I made a whole game where the goal was to just destroy everything, and I made a bunch of cars that all had different parts. So the car had a bumper and a hood and lights and doors and a trailer and stuff. And they were all separate game objects, all with their own rigid bodies connected by joints that made it actually, when the car moved, the wheels would spin because they were on hinge joints. The bumper would stay exactly where it was relative to its cab because it had a fixed joint. I had another hinge joint connecting the trailer so the truck would turn and the trailer would follow and stuff. But I wanted to be able to break those things. So what I did is I just set those brake forces to appropriate values, and that way, here, we can do this now, brake force, it's all kind of trial and error on this because it's hard to guess these forces that they're involved in. Right now the brake force is 1, and you can see they broke apart when they hit because the force the joint experienced was greater than that. And now if I did something 50, hopefully it won't break. Wow, damn, it's weak ass. How heavy is this thing? Let's just try 500, 5,000, sure. Yeah, I think in one of the recent Unity updates, they upped the actual force amounts so that where a typical braking force for a 1 unit mass dropping like a pretty small distance, you could have like 15 to 50 brake force and it would survive this type of collision. Now I got to up it to about 500 to 5,000, but I can actually modulate this on the fly and just drop it to see where the braking point is. Well, it's kind of slow, but you get the idea. Brake torque is the same, but instead of linear force along the joint, it's torque. Enable collision. You check this when you want there to be collisions between this object that you're dealing with and whatever connected object that the joint connects it to. So sometimes you may not want them to collide with each other, but they will still collide with everything else. This is a nice way to just do that. Pre-processing, I've checked this and unchecked this. It doesn't really seem to do anything. It says disabling joints pre-processing helps stabilize impossible to fulfill configurations. And when you have kind of like lots of joint systems and they're all colliding and banging, sometimes they'll like jitter and freak out. Apparently, if you turn off pre-processing, it might help deal with that, but honestly, I don't really think that ever works. So that's a fixed joint. It's very boring, but useful. Here, where we go. Pendulum. So this is a hinge joint. Joints are cool because, specialized ones like this hinge joint, they start giving you these little axes arrows. So that indicates that this is the axis that my hinge is based on. And of course, when I hit play, if you haven't seen it before, it will spin around this guy. Now the hinge joint is super cool because it's got all these additional features. It's not just like, I will allow you to swing. Where's my hinge joint at? Here. You can specify the anchor, so like exactly where the hinge is relative to the object the joint is on. I can specify the axis, so completely any vector you want in space can be at any angle. Use spring, so I can check this. I'm not sure it's going to do anything because my spring's super weak, but it will basically add like a kind of mousetrap style spring, radial spring to that hinge. Use motor, which is what I'm doing right now, is where you can actually apply a force in the right-hand rule direction to your axis. And of course, it's got a target velocity, which it will attain by using this amount of force. Free spin just allows it to spin in either direction. Limits, basically, if I say use limits, and let's say max is like 90 or something, I just pop that on. No, you see how freak out? Now this is 90 degrees for it. It can't move past that limit, so I can then turn that off, and it will spin freely again. But if I tell it to go back on, it'll freak out. Maybe that's pre-processing. Cool. But yeah, you can specify the min and max, and this is again very useful for stuff like doors, where you don't want the door to swing like completely 360 degrees around the thing. You want it to be nice. So you can specify all this stuff, and if you can only imagine like these really basic things, you can connect two things together, they won't move. I got a hinge type deal over here. It's got a motor, it's got a spring, it's got limits. Like I can really build physical, mechanisms in Unity. It's very cool that you don't need to code any of this. I haven't touched a key. Again, this also says brake force, enable collision, all that stuff. And the limits have their bounciness and stuff like that. Let's see over here. This is an example of the spring joint used on a hinge joint. The spring force, sorry. Give me a lever. This is the hinge joint. So right now I've got this little projectile guy right here, which has a rigid body. So it's going to react to gravity and stuff. It's not connected to any of this stuff. It's just hanging out over here. I've got this cylinder, which I think is just for show, really. And then the lever, this little platform, I built a little catapult. Check this out. So I've got a motor. I'm using actually all of these little add-ons right here. I've got a limit saying it can't move past this relative horizontal right here. I've got a motor telling it to pull itself all the way back. And I've got a spring telling it to push forward. But right now I have my motor on, and the motor is more powerful than the spring, so it's allowing it to kind of hold itself there. Now watch as I turn off the motor. Wow. There's a freaking catapult. I didn't touch one line of code. Like that's got to be worth something. That's pretty cool. Well, let me think of what other joints that I didn't really cover too well here. I think you got a spring joint, which is a free axis spring. Basically, you specify it a target distance, and it will apply a specified amount of force to attempt to return to that target position. It's got a damper, and it's got drag and stuff like that, where you can say, oh, I want it to be really bouncy, or I just want it to like pull it back and then stop. So that's That's a useful one too. There's a wheel joint. Oh, looks like they got rid of the wheel joint in 5. And of course, all of these things have analogs in 2D. Like distance joint 2D is the same thing as a fixed joint. Hinge joint 2D, slider joint 2D, it's the linear motion, spring joint 2D, wheel joint 2D. And then you got the most powerful joint of all, which is called the configurable joint. I love saying joint so many times in a serious context. It's great. So configurable joint basically contains the functionality of every single other joint. You can specify 2 different axes on which it will operate. So for instance, you could say, oh, my primary axis is local up and my secondary axis is local right. I can have a spring going this way, I can have a hinge going that way, and I can have a motor on the spring, and I can have it fixed over here, or it can be, slidey along there. So this one is very interesting to use because you can really get any kind of movement. For instance, when I was making a chain, I made a physical chain that is just a bunch of links all linked together with enable collision check so that they collide with each other and have this realistic kind of flow to it. They all use configurable joints because a single hinge joint would just allow it to swing this way, but not this way, or not move up and down. So a configurable joint, you're allowed to move all axes and even jump up and down a little bit within limits that you can supply it. You can specify bounciness, all this stuff. But for the most part, it's overkill. If you just want to use one part of these things, it's better to use a lighter joint because you can see here it's got a billion little things: a slurp drive, angular XY drive. And I'm not a huge fan of the way they set it up because Unity likes to cut things up into XZ plane and the Y plane, or sometimes YZ. They like to separate things, and I'm like, just treat them all separately. They deserve it. They're freaking coordinate axes. So, but this is a very, very powerful joint, and you can really go nuts with this and get very complicated functionality. So, where am I at here? Everybody's pretty satisfied with the physics. I'm going to get into the meat and potatoes, go into scripting. Yeah. Okay. Scripting. So you're like, well, I've been doing this whole time. You haven't touched a line of code. And I'm like, well, that's kind of great. You can get a lot of functionality without touching code. But of course, we're not here to fuck around with boxes. We're here to write some programs. So where my scenes at? Scripting. Yeah, whatever. All right. Very destitute scene here, but for the purpose of this lesson, it will be fine. I haven't talked about materials yet, really, but I'm going to touch on that later. It's fairly simple. It's just tough to here, if you look at the game view, everything's white. It's very hard to tell if you're moving or not. So I'm just going to go ahead and throw on the floor some sort of material with a pattern on it so we can tell that, orient ourselves a little bit here. The ground. Sounds good. There we go. Look at that. Okay, so I've got this little ball guy here, and let's see what we need to use force. Let's not use force now. So I made this little script over here. It's called Movement Controller, and the way you make a script is hopefully you made a scripts folder. Another convention is I usually start my scripts folder with an underscore because it just shoves it to the top of the hierarchy, which is alphabetical. So the underscore will come before most other things, and you're going to be accessing the scripts folder a lot, so it helps to shove it up to the front and not search for all the S's. Over here, so what you can do is when you're in the project, you have to be in this project window to create scripts. You can go right-click, create C# script, JavaScript. I don't even have Boo script anymore. Lol. Yeah, Unity has 3 supported languages, which is C#, JavaScript in air quotes because it's not really JavaScript, and I guess they don't have Boo anymore, but they used to have something called Boo, B-O-O. It was like a weird hillbilly trailer baby between JavaScript and C#, and it was like, what the hell were you thinking you need? Nobody's gonna use that shit. Apparently, enough people didn't use that shit that it's now gone. So don't use Boo. If you're a big fan of Boo, I apologize. JavaScript, I'm just gonna say I don't use JavaScript. I like my static typing. I like my .NET. And JavaScript itself, having var all over the place, you have no idea what the hell var is. Is it a vector? Is it a game object? Is it like a string? I don't fucking know. It's a little annoying to go through your code and be like, looking for errors and being like, what the hell is this thing? And you have to look all over the place to find it. It's very nice in C#, and you're like, it's a frickin' float. It's a vector. I know exactly what it is because anytime I talk about it, there's vector operations on it. So I'm going to go ahead and do C#. As an opinion, I suggest people code in C# just because most serious game developers code in C, C++, C#, which is a lot closer to C# than JavaScript is, for instance. So you go ahead and do that. It'll ask you to name it. Now this is pretty important. Don't screw up the name, because if you do and then you change it in the script itself, Unity's gonna get a little confused and you're gonna have to re-import and it might mess some stuff up. So just get the name right the first time. So I guess I'll start from scratch and I'll just go move controller, type it in there, hit enter to confirm, and you can double click it or hit enter to open up this newly created script. And it will open MonoDevelop. Some of you, it might open Visual Studio. That's like a newer, if you just downloaded Unity like very recently, it might do that. Let me know if anyone experiences this and I will tell you what to do. But assuming we're all good. So this is a MonoDevelop, which is Unity's kind of like built-in standard code editor. I actually really like it. I have Visual Studio. I use Visual Studio a little bit, but I don't know. I just got really used to the Unity thing, and it does have the built-in, auto suggestions and the corrections and stuff. And it has a debugger and unit testing. It's not terrible. It's if you like Visual Studio, I would say use Visual Studio. It's probably better, but I don't know. I like my MonoDevelop. Looks nice. Anyway, so you'll see off the bat it comes stock with these namespaces. It goes using Unity Engine, using system.collections. So these are the libraries that it's going to be pulling from to get a lot of this functionality built into Unity. So for the most part, using Unity Engine, you're going to need that. You will definitely need that. And system.collections, that's just like arrays and array lists, I think. But a tip, I like using generic stuff a lot. I don't know if you guys know about like generic typing and stuff, but I like my like linked lists or array lists or stacks or queues. If you want any of that built in, all you have to do is I usually just copy it, go using system.collections.generic, and boom, off the bat I can go list of whatever vectors, boom, and it knows it. And it's got stacks, queues, heaps, trees. It's awesome. So usually off the bat, it's not necessary to do it if you're not going to use that stuff, because it's just a waste of a using namespace. But if you're going to use that stuff, just keep in mind you have to import it via that. It won't show up by itself. We're not going to use that here for now. So you also see, if you're used to Java or something, C# looks entirely identical to Java, which is what I love because I grew up doing Java. So we got public class moving controller, and then this weird colon mono behavior. So in C#, this colon means it's inheriting. This is inheritance. And mono behavior is the Unity runtime kind of base class. Now mono behavior, unlike if I were to just dump this, it would just be a public class, which is just a container, and it won't necessarily interact with the game world in the same way that mono behavior scripts do. So for instance, mono behavior scripts have something called callback functions, which is that once you start running the game, there are certain, like I was talking about collisions, to register with collisions, there's a callback function called void on collision enter with some parameters that will be called when your thing has a rigid body or a trigger or whatever and a collider and has this script attached to it that inherits mono behavior. If it doesn't inherit mono behavior, all this thing start, update, fixed update, collision callbacks, all those callbacks will not ever be called. They will not happen. So for the most part, unless you're making like classes that don't inherit mono behavior for like data packaging or custom like objects that won't really be in the game world, leave mono behavior on it. It's good. So start is the first callback function. It gets called as soon as the game wakes up in play mode. So usually it's useful to like initialize variables here, or like call any functions that you need to set up, your game object and stuff. Update, this is where the real magic happens. This is where the game loop really exists. Update is called every frame in Unity, which is between like 50 and 100 times per second. So this is like the, what what is that? The mitochondria of your script. You know, this is the thing that drives it. It always calls, it always updates until it's destroyed. So this is where you can make things become alive, and it's beautiful. So I already had a script prepared for this. Let me just open that up so I can remember what I'm doing here. It's this one. Yeah. Yeah, so I would go and type all this out again, but I'm actually kind of lazy, so you can just look at this. I don't know, I'll show you this cool thing. So what is super cool, the first time that I did Unity, this kind of just, I thought this was really cool. I can start declaring my variables, blah, 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 just like every other thing. Okay, we are a movement controller, right? So we want some max speed that we can move our little ball around, and we're going to just keep him in the XZ plane. So I want to go public float. Another caveat is that I think there are doubles in C. I don't use doubles. There's ints. I use floats for the most part. They're nice, but when I go public float max v, right, equals 3, and I try to compile this, and I'll go back to Unity, and you can see in the bottom right corner, you'll have this little wheel that spins, and it goes, I'm compiling. That actually didn't give me problems, but if I actually tried to use it, it would give me crap. You need to say 3f. That means it's a 3 float. JavaScript doesn't have that problem, but whatever, JavaScript, you're not that cool. So I'm just going to kill that for now. So I can start defining my variables and go, okay, public float max v, what else do I have? Okay, and it's not necessary. Whatever, like public vector 3 forward. I'm not going to actually use this, but just so you can see. Now I let Unity compile this. Boom. And I'll make a little sphere bra. Nice sphere bra. And I'm going to just raise you up a little. Now I'm going to go ahead and drag and drop move controller onto the inspector for the guy that I want the script to live on. Move controller, you see, and now it exposed these variables to me, max v and forward as a vector. I can actually input these values just from the Unity editor, and that will be used in the script once the script starts executing, which is very cool. So you don't necessarily need to have all these variables defined in the script at all. It's perfect for, you know, when you have a character and you're not sure how much force you should be using to drive him. So you just leave these variables open, and you say public, I can edit it in the inspector when I want. I can code all of these things as if they had a value, when really they just default to 0 and stuff. And then I just can play around with these numbers without having to go back into the code and be like, all right, that was too fast, I'll change that 5 to a 3. And you can just do it all through here and just drag and drop, change values, copy and paste. It always shows. You can edit like actually quite fairly complex like structs in here. Like a vector 3 is a struct, and you can actually edit its pieces, just x, y, and z, from this inspector just by going, oh, look, I have a public variable called forward, and it's a vector. Now I can manipulate it from the editor, which is very nice. Actually, I'm going to use that. So this is my little movement controller script. I'm going to explain this a little bit. So start is kind of the first thing that gets called when the script starts running. Technically, there's another callback called awake. And this is actually an important distinction to make because awake is called a lot sooner than start is. Awake occurs the second that object exists in play mode, whereas start gets called after everyone else's awake has been called. The order of execution of scripts, which is much more detailed, you don't have to worry about that. It's kind of random, but you can specify it. So awake is useful for setting up references that stuff in start might call, and you'll get a null ref error because it doesn't exist yet, because your start has been called before something is else's start is called. Awake ensures that it will always be first. So an update, I have a little if statement that go, I have a use force because I'm going to show you I can either control this player by pure translation, like just manipulate its position, or with actual forces in physics. So I go, basically I have two different modes. I'm going translate, which is literally just updates its position based on the input and our axis, which maps to WASD and, the arrow keys. You can also map it to whatever you want, and direction. So yeah, I'll just show you how this works. Public will use force, so we're not going to use force for the first time, and I'll show you what happens when you use force the second time. Boom. All right, this little sphere is just a demo we're not using. This is the one I have with my movement controller on it. It's got a rigid body. It says use gravity. Doesn't matter. I'm going to check is kinematic to show you that I'm going to drive its behavior purely through scripting. So we don't have use force. Vmax is 20, I think. I can just set this to like 5. We're going to go ahead and play. And now just using the WASD, whoa, yeah, 20 is, or 5 is even too high. It's like 0.5. And let's get this camera to follow it. So like I said with the parenting thing, the camera, you can see the little preview down here is looking straight at our little bro. I'm going to go local so I can pull it back along the camera's view. And then I'm going to parent this camera to our player controller so as it moves, the camera will follow it. Hopefully it doesn't fly off again. There we go. So I'm literally just, the script, all it does is it goes, if I'm pressing down, you know, the left key or the right key or whatever, move it in that position by a very small amount, since this is getting called like so many times per second. So we'll see in the script here, the exact way I do that is go x, I'm making some local variable called x, it's equal to our input.getAxis raw, which just means getAxis, it has horizontal and vertical axis, which by default is mapped to, as I said, WASD to the arrow keys. GetAxis raw horizontal is going to return -1 if I'm pushing left on the arrow key or the A key, and +1 if I'm pushing to the right, and 0 if I'm not doing it at all, and vertical the same for up and down. I'm storing a new vector called direction, and basically what I'm doing is I'm taking my, since I'm moving in the XZ plane, right? The vector goes X, Y, Z, so I take the horizontal, that controls the X, 0F because we're not changing its direction at all vertically, and then forward and backward is our Y. Should it be called Z, but whatever. And then I'm just saying, all right, our new position is our old position, transform.position, plus this direction vector that we created, times the variable we had before, Vmax. So basically this direction thing is going to be pretty low. It's going to be around 1, right? Since the most it could be, the largest magnitude it has is, I think, √2, right? So we want to multiply it by Vmax, which allows us to say, all right, we can just take this normalized input, which is going to be ±1 here, take that vector, add it onto our position. Now all we have is a heading, and then we just we scale that heading vector by Vmax, our max velocity, which we can just tune at any time from the thing. And that is telling us where to be in the next frame. Now notice we're calling this an update, so we're going to update its position like a whole shitload of times in like 1 second. So that's why you want to keep these values pretty small. This is why I have it at 0.5, and it's still moving like quite fast. Now I'm going to do it with physics instead. So I'm uncheck kinematic here, and I'm going to go use force, and I think I need to raise this number a lot since instead of telling it increment by this amount, we're going to add forces, which is going to build up over time. Let's see the results. Whoa. Yeah, that's cool. I didn't attach the camera to it before, but basically since we're adding force and there is some friction between this thing, it's going to roll instead of just teleporting, right? So this is a whole interesting game idea right here. It's like, you're drunk as fuck, try to get home. Whoa. Now I can just unparent the camera so you can see that it basically does the same thing. Now the camera's not going to follow it and not copy its rotation, so it's not rolling all over the place. And you'll see we get the pretty much same effect as before, but our ball is actually rolling now, which is an interesting side effect. But you can kind of notice it looks much more natural, you know? It doesn't look so like robotic and jittery, and it's because we are driving it through forces instead of updates. The force code looks almost identical, you can see. I do the same thing. I grab the axes, I specify the direction using those axes, and instead of saying transform position equals this new position, I go get component, rigid body, because like I said before, this dude has a component called a rigid body, which it needs to react to physics. So we're going to get the reference to the component and call the function add force. And add force calls, when you call add force, it's going to ask you for a force vector, which is the direction that you want to apply the force in, and the length of that vector is the magnitude of that force, and a force mode. And you have 4 different force modes. They're acceleration, which means that you're going to apply this force over a long time. So if you saw here, it steadily kind of starts rolling and gets faster as we add more and more force because it's happening over a small time increment since it's an update. Now there's also impulse. An impulse adds force instantly. So that's very useful for like gunshots and stuff. You don't want to be accelerating this bullet over a long period of time. You just like, I just want to call add force once, boom, it shoots off. So I'm going to go ahead and change this to impulse. and show you that I'm just going to tap forward once, and it's going to fly off. Compile. Okay. Boom. All I did was tap it, and it just, boom, it adds that force immediately as opposed to over time. And now acceleration and impulse have their counterparts. Acceleration and impulse take into account the mass of the object. So obviously your force vector will need to be larger to move a heavier object. So you also have these modes called velocity change, which is the equivalent to impulse, except it ignores mass completely. It just goes, I don't care your mass, I'm going to apply this as your velocity is going to change by this much. And force mode.force, which, oh sorry, yeah, acceleration doesn't use mass. Force uses mass. So force mode.force, that's not the best way to name it. I wouldn't use that, but whatever. I'm using acceleration because I don't really care about the mass of this guy. So when we're scripting, you may be like you may be great at Java. You may know every C trick, but it really all comes down to the Unity API, like vectors, input, right? This stuff, rigid body. You could be great at all these languages, but have no idea how to use Unity because you don't know what the API is with these things. So what's great, what I like about MonoDevelop is I can go, all right, I don't really know what the hell I'm doing, but I know I have this rigid body. So I'm going to go get component, and it suggests, oh, look at all these things I can do. Get component in parent, so I can grab my transforms parent, get component in my children, get components, I can get a whole array, get components, and blah, 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 get hash code. So yeah, it suggests things for you, and like so much of the time, like, I want to do something, I don't know how to do it, let's just start typing and see what comes up. So I'm going to go get component rigid body, needs a type, which is the big blue. And then you need to do this little thing because it's technically a function called get component. And I can just go dot as if I'm going to call a function, and I can just scroll through and look at all these different things I can do. I can grab its velocity, I can ask if it's using gravity. And it tells you in this little summary here, oh, you're going to be getting a bool and you're allowed to set it as well. Use cone friction. I have no idea what that is. ToString, sweep test, they're all these great things that you may not really know what you're doing. You can just kind of browse through and be like, add explosion force. I kind of want to do that. That sounds cool. And it tells you, oh, explosion force, explosion position, explosion radius. It's fairly self-explanatory. So really just explore, look up the API, but if you got something in your head you want to try to do, just start typing stuff.
Apply an infinite impulse?
Sorry?
An infinite impulse.
I think we're going to get the same problem. It's going to be like, nah, you can't infinite, bro. Okay, as I said before with collision stuff, I'll show you a bit of that. The callbacks look like this. What is a little annoying is that you don't have autocorrect for callbacks, so you kind of have to know what they are. Void, you can't specify a private on these because they're inheriting from mono behavior, and it's going to be like, oh, you can't override something and change its protection settings, so just type void. It's just protected. On collision, enter, and now if you were in 2D, you'd say 2D, it's that easy. And then it takes a parameter collision, and you can name the collision whatever you want, other. So basically what happens now is if our guy's going to register a collision, this function will now automatically be called when there is a legitimate collision event, and it will pass in that collision event's data here. So we can then grab, we're like, okay, let's say I want to know what other game object I collided with. I just type other, dot, and now I can go get all of its information and all the information of its parents and siblings and children. It's like a super creepy Facebook for code. So this is one of the things I want to talk about scripting. It's like, all right, look at the type we got here. We have a collision type, right, other, but we want to get the game object. We go collision dot game object. And now we go, well, maybe I want its transform, dot transform. Now maybe I want to get its rigid body, dot, oh, they don't do that anymore, but that dot get component, because we can call get component on this guy, rigid body. And then we can just go back and forth, dot transform, dot game object, dot blah, blah, blah. What I'm basically trying to say here is that you can really access any parameter that's attached to any other object as long as you're able to get some sort of reference to it. And it can be like the puniest reference ever. You can get its material and actually go all the way back up the chain and get that guy's transform or rigid body or whatever. So it's very robust. That it's kind of like all part of being a good programmer in this sense is like I want to use the smallest amount of resources and get the most amount of information that I possibly can. So we're getting this collision thing. Let's say, you know, we could pass in a transform, we could pass in all these other things, and you can just go crawl through the hierarchy of its components and grab anything else that you may want. And I can even go transform.parent.parent.parent.parent, and I can just go all the way up the chain and get all sorts of crap. So it's very, you can really get anything you want as long as you just have the lamest reference to that other object. So you got on collision enter. For each of the different types of collisions, you've got on collision enter and on trigger enter. Trigger is, of course, when you have the trigger, is trigger checked on the collider. The only difference there is, I told you, the trigger colliders, it's not going to register collisions. It will just alert you that something has passed through it, but the other object will treat it like it's not there. They each come in 3 flavors. You have on collision enter, and this is called the second that 2 colliders intersect at some point. And you have void on collision stay, which is called every single frame that the 2 are still in collision. And this also takes collision other. And then you got on collision exit, which, if you can guess, gets called as soon as the other collider has finished a collision with it. And that also takes the parameter collision other. And then trigger has the same thing, on trigger enter, on trigger stay, on trigger exit. So you can really use these to do a lot of things, like maybe you want to explode the grenade as soon as it contacts something. Or maybe it's a sticky grenade and you only want to explode it after it's been in collision with a dude for like 5 seconds or something. All sorts of crap you can do with it. So those are, that, update, start, and awake are really the most important callback functions that there are. You're going to be writing your own functions, of course, and those are all going to be being called from these various guys at the right points and stuff. But as long as you know those are the very critical ones. Let me see. Yeah, as I said, you don't have to inherit from mono behavior, but it will not get those callbacks, and you won't get. It won't be like a living game object. It'll be like a class, like a container, more like that. So yeah, if we want to grab input from the user in any way, we have the input class. I'm just going to run through quick, like a couple of important, built-in classes. So we go input dot. And we can see all these different things. Acceleration, if you have like a mobile device with an accelerometer, this will actually give you a vector representing horizontal acceleration, vertical acceleration, forward and backward acceleration. All these counts, any key, it's like if he hits anything, blah, blah, blah. But most of the ones you'll be using is get axis, get button, and get key. So get key is cool because you can just go get key, and then it'll ask you for a enumeration, which is just the key code thing. So I can go keycode.a, or maybe I want space. Oh, whoops, I can't do that, obviously. Dot space, dot left shift, left alt, left apple. Look, they even have left apple. Left parentheses. So you can grab any key you want, custom map your own controls there. The other most important one is input.get mouse buttons. Mouse button. This gets a little confusing because you have get mouse button, and it takes an int. Left click is 0, right click is 1, and middle click, if you have it, is 2. And then you have input.get mouse button down, and get mouse button up. Get mouse button, this one right here, it will, again, like on trigger stay, it will be called every time, every frame that the button is held down for. Just on down is only on the frame that the thing is clicked, and get mouse button up, it's a bool, it'll tell you if the mouse button has been released. And then you got input.mouse position and all that stuff. Like I'll leave that to you guys to figure out. But basically, input class is where you get input, believe it or not. So I'm gonna get into some funner stuff now. Yeah. Anyone have questions on scripting? Like it's again like I kind of just want to teach you how to make a script, how to apply it, how it kind of looks on the thing. But the actual coding part, I'm not planning on covering. So if y'all good there. I'm going to show you terrains. So here's a little demo scene I made of terrains. I'm just going to hit play. Terrains are basically a deformable plane, which allow you to specify height and stuff. Anyway, let me maximize this. But I made this terrain in like, I think 20, 30 minutes, something like that. once I had all the assets, I had to go and draw the grass and the leaves and the trees and the rocks and textures. That takes a long ass time. But building the terrain itself, once you have these things, I can walk around and see all this elevation and stuff. This mesh is actually extremely efficient and has built-in colliders. And this is all within the Unity's terrain class itself. So you don't actually need to like go into a 3D modeler and build this mesh. You can just use a kind of like MS Paint style raise height, lower height type deal to craft these terrains. And you make beautiful, stunning things. It's got auto-placed grass. You can mass-place trees. You can add wind zones and all this stuff. It's very robust. It takes a lot of getting used to like, you know, kind of figure out the terrain business. But once you do, you can do really beautiful, like AAA game type stuff in there. I'm not gonna get too into that. I was gonna do UI. I don't know how much you guys care about UI. No? Yeah. Okay. So I'm just gonna show you guys some cool stuff then. Let me open the project of mine. Oh yeah, I was just working on this one. So I was watching a lot of Green Arrow, stupid TV show, and I was like, yo, fuck it. I'm gonna make a dope ass bow simulator. Let's see what we got here. And again, this was I made this in like an hour or two, just fucking around. And God, I name everything test when I'm starting out. All my scenes are test. That's bad practice. Don't do that. Terrain test, animation test. It's like test is like I end up like my main scene in the end is labeled test. Name it. Anyway, all I really did was these are just cubes. This is the terrain I said before. I 3D modeled this bow. You can see a little thing and the arrow. But aside from that, it's pretty much just a tiny bit of animation, a little bit of scripting, and a couple bit of physics there. And I have animations for reload. You can scroll the mouse wheel to change like how much bow strength you want. So not so much bow strength, maybe a little more bow strength. Went around. There's a little zombie guy doing. Not finished yet. And this is again the joint system I showed you. This is just a hinge joint with a motor on it. Boom, I can shoot crap. And I'll show you the code for this. It's like less than 100 lines long, I think. Let's see. Key turn to the FPS controller. Bow. Yeah, bow controller. Yeah, it's not very long. A lot of it's just kind of more fun little functionalities, but it doesn't give me a line count. But it's very short. You can see there's a fuck ton of variable references I need, but a lot of this is just like animation triggers and stuff, and the actual functionality of shooting the arrow is extremely easy. And this was mostly done through physics. I just have the arrow, which has a rigid body. I set it to kinematic because I want to be able to move around and walk with the arrow held without it flipping out, because it's like, oh my god, I'm moving, but I'm a rigid body, oh my god. But no, it's kinematic, and then the second I want to fire it, I just set kinematic as false, and I have a little cam follow over here. I can hit tab and follow it, boom. Now I'm here, and you can see, look at me. So the camera's mounted. I just parented on the fly during runtime. I just made the main camera's parent this bow, the arrow right here. So it just follows that. Boom. I can tab to switch out, and blah, blah, blah. So again, this is something, you know, that's a lot of fun. Like, I'm not sure if I'm going to make a whole game on this, but I was just fucking around, and this is pretty fun. It's like no scripting. Once you get the basic ideas down, you know, that's all there is. Let's see what else I got. This little, I guess I'll show you that cool AI thing going. This is a bit more advanced stuff, but I'm basically building an entire ecosystem with AI animals and plants in it that all react, you know, based on personalities that they are built into, that are randomized, and, you know, random resource generation and stuff like that. But this is kind of like what you can do if you really sit down and say, I'm gonna code the shit out of something here. Let's see. God, I hope it didn't go test. Oh, this is the tutorial. All right, whatever. While I'm opening this thing up, does anybody have questions or just like want to know something else, or like want me to talk about something? Like, please hit me up. Like, what are you guys interested in learning? Are you guys gamers?
Yes.
Yeah, pretty much. Not even like a huge gamer. I gotta say, I stopped playing games a lot more when I started making them, because it's way more fun to build them than to play a lot of these crappy games out there. And it's kind of great when you're like, damn, that game sucked because of this, this, and that. I'm gonna fucking do it. I'm gonna do it right now. So Sorry?
Networking? Like I'm interested in making multiplayer games. So how?
Unity has a really robust built-in networking infrastructure, like network class and all that stuff. I've done a couple multiplayer games. It's complicated. It's just a difficult thing to get a hold of in general because of the whole server side thing. But Unity does make it very easy, and they have their own servers which allow you to host games and do matchmaking and type of stuff. But it's just a little more involved because you have to start dealing with your model. Are you like server and then everyone's a client, or are you what's it called? Local hosts. Like I forget what that's called. But you kind of have to figure all that stuff out, and it's like it's a bit of a big project. Let's see, environment, FP controls. This is that. Like, if you want to do like a first-person shooter in Unity, it's actually like you can do one fairly quickly. And of course, I always recommend going to this Assets tab, Import Package, and they have all these built-in packages that are just come with Unity. Like cameras will give you all sorts of effects that you can put on your cameras, like lens flares and sepia or whatever, full screen effects. Characters, this will give you 3D models that are already rigged and animated with animations and scripts that already allow you to just off the bat import it and be able to walk around and fully control a third person or first person character without you having to touch anything. And while this is great and all, of course, you should learn how to do this. You shouldn't just be throwing all this stuff in and being like, oh, I'm pro at Unity now that I can import other people's packages. So. But if you know how to do some of this basic stuff, it saves a lot of time. You're just like, I don't want to fucking recode that same thing I wrote 50 times. Just import the character script. And they give you a ton of stuff. Effects. Environment gives you a lot of pre-built terrain stuff. Like they give you grass and tree textures and all this stuff. So you can just like get started very quickly. Vehicles, again, these are all, they give you prefabs and all this stuff. Oh yeah, I forgot to mention prefabs. Real quick, prefabs. A prefabricated object is when you've created sort of, some object that you want to reuse later and stuff, and you've built it in your little scene, but you're like, oh man, I want to use that in another scene, or I want to be able to dynamically instantiate that. Literally, all you need to do to make that like a saved sort of object that you can pull from at any time, like that exists in your file browser. Because you'll notice this stuff here in the hierarchy, it exists in the scene, but it doesn't necessarily exist anywhere else. It might only live in the scene. So to be able to make stuff accessible, you literally just like here, look at this guy. You just drag it in. Notice how it turns blue? It's now a prefab. And you can see in the inspector here it says .prefab. And now you can go reference that to other things and etc. But very easy but important concept. Prefab stuff like bullets that already have textures, materials, effects, scripts built in on it. Already maybe they got moving parts and crap. Just drag it into your project in a folder called prefabs, and then you'll be able to use it again wherever you want. So I'll just give you a quick run through of my AI game. So this is the game he was talking about where you don't have to play it. And it's very heavy because I got nav meshes and stuff. There we go. So right now, it's a whole open world environment, and there's a ton of little creatures. God, it's so slow. Yeah, next time I'll bring a cable converter. All these little guys will wander around. They get hungry. They look for food. Fruit grows on the trees, they drop. This little dude here, he's like a Venus flytrap looking dude. When he gets hungry, he'll snap at these guys. Everyone's animated, rigged, and they're all kind of randomized. So I'm actually in a chaos theory class. I was very interested to like kind of track the dynamics of like a multi-trophic tier ecosystem and kind of see if you'd be able to roughly predict like, all right, given X predators and Y herbivores and Z trees that produce fruit at some rate R, like which one of those species will become extinct and like how quickly, and which will overpopulate and grow and flourish and thrive. And I don't know, because in the class we've only done like very simple stuff, but I'm sure it'd be very useful to use to predict, and so I would know like how many predators to place in the scene if I don't want like the game to just become extremely overpopulated or completely barren after like a couple minutes. But I've actually had this run for like 6 hours without anything horrible happening. So that's a good sign. Oh yeah, these big old dinos, they're so cute. And they search for, and these are all AI, they're all automated, and their script it's hefty, but it's not ridiculous or anything. And I'm using a very useful built-in Unity feature called a nav mesh, which you can see here. Whereas if you want to have AI characters, you simply take a terrain or any other surface that you want things to walk around on, and you can just tell it to basically overlay. It'll calculate which areas should be walkable based on their height and their slope, and you can tell it what the max slope distance should be that shouldn't be walkable by certain creatures and stuff, and step heights, like they can walk upstairs of only a certain height, blah, blah, blah. And then they have all these little moving creatures have components called nav mesh agents that basically link to this nav mesh and are able to say, okay, now I can tell them to move to some random point, and instead of just moving in a straight line to it and possibly hitting a mountain, they will like very intelligently move around obstacles to get to that point and avoid things you tell them to avoid and not walk on places like water or lava or something. And again, this is without any code pretty much, except for like telling it where to go. It has a nav mesh agent on it. You really just need to give it a place to go and make sure you have a nav mesh where it can walk on. And that's it. So that was just a quick run through Unity. I'm sorry I had to cover like a lot of stuff in a very short amount of time. So again, if you guys have any questions, now's the time. But that's the basics. Yes?
Can nav meshes be baked on via script, or does that have to be done in the editor?
Theoretically, you could, but it's really slow, and they'll probably just crash your game on the spot. It's not something you'd want to do. But why are you thinking of like having dynamic level generators?
Yeah, it's because for 361, the semester game project is like you have to make a procedurally generated open world. We're using Unity for it, so I was wondering like if you could like during like, the startup of the game, right, bake the nav mesh on it without having to.
I think you could. What you need to do first is create like you could do a flat terrain, right?
Right. Yeah.
Bake the nav mesh there, and then you can update the terrain's height and stuff over time, and then tell the nav mesh to update, which would be a little quicker. But the smarter way to do it is what's called a additive load level. So I can transition between scenes by calling load level in script, and that basically says like, oh, I want to load level, main menu. All right, now I hit start load, first level, blah blah blah. That will transition from one scene to the other. That's just the default load level. There's also something called load level additive, which is great for open world type stuff. Whereas I could define like 50 of these and save them all as separate scenes. And let's say like I walk towards here, and I go, once you get a certain distance away from this place, load a new level, but keep the old level where it is. And now we'll stack that other level on top of it. And then you can unload this level once you're far enough over here, and that way you can kind of just walk infinitely, and wherever you go, you can just load additively a new level in that new zone, and kind of continue forever. You're in 361D?
Yeah.
I did that last term. Your project sounds a lot more fun than ours was. Anyone else? You guys all pros already? Wow.
Very basic question of like how to make the like 3D models.
Ah, thank you for reminding me. I was going to mention some free software that I use. Okay, well, very good question. How do you make all these 3D models and textures too? Because like how do you get this grass stuff? These are all what we call like game assets and stuff. Unity has a store, right? It's called, you can go to Window and then, what is it called? Asset Store. And this opens up a little window, and then you can like shop around. You can make a Unity account and pay money, but there's a ton of free stuff, like a ton. From 3D models to scripts to completely rigged characters and all that stuff. So if you have no experience 3D modeling or any game art type stuff, I'd recommend starting off there. But if you do want to start getting into 3D modeling of your own, I use Blender. Now, if you're a fat cat and you can drop like 10K on Maya or Autodesk, all that stuff, do it because it's awesome. But I will tell you that Blender is like 99% as capable as those things are, and it's completely free. There's a ton of online tutorials. There's a ton of add-ons, and it's actually scripted in Python. So if you know Python, you can actually write your own code as little add-ons and tools within Blender itself. So I am an avid 3D modeler. I love doing it. But I will tell you, it's a lot of work to learn how to do this stuff. It's not like just jump in and start doing it. It's all very, it's a very difficult thing to learn. Like, But this will cover, the modeling itself, the rigging and animation. Like this is the little guy you saw in my earlier thing. This is its skeleton, which I then animate by moving it around and posing it in different places and all that stuff. And its mesh itself isn't a static mesh, but it's kind of like a rubbery skin that bends around the bones. So you can get like really crazy if you want, and make like very professional stuff in Blender. I've seen like unbelievably professional stuff made in Blender alone, and it's completely free. So that's what I suggest personally if you can't afford Autodesk or Maya, those things. Texture-wise, if you have Photoshop, I don't really care about advocating piracy because I pirate like everything, but go ahead and pirate Photoshop. Like no one's listening, I hope.
We are recording this.
Oh, I was just kidding, Adobe. I totally paid for mine, and
that part out.
yeah, beauty of editing. But another great free alternative, which has the jankiest name you ever heard of, it's called Paint.net. And when I first heard it, I was like, really? The best free alternative to Photoshop is freaking called Paint.net? All right. It's actually really, really legit. Totally free, tons of add-ons. It's very intuitive and easy to use. I do have Adobe stuff that I totally paid for. And I still use Paint.net just because I like the workflow better. It's very light on the CPU. It's kind of like, it's basically Microsoft Paint on steroids. So I use that. Again, for more like vector graphics, for like UI type stuff, here I'll show you my vector graphics library. Where's my UI? Here, icons. So I don't know if you guys are familiar with the SVG format or vector graphics format. Yeah, but it's infinite resolution, which is very cool. They're all defined by things. So you get these like beautifully perfect crisp lines and stuff. Adobe Illustrator is what's most commonly used for that. I use another free program called Inkscape. Inkscape is very legit. You can even do like 2D animation in it if you really wanted to. But Inkscape is another great, completely free tool for vector graphics. And I do all my vector graphics design even though I do have this really nice, swanky-ass Adobe Illustrator copy. It's just because I really like the controls and the interface. And frickin' Adobe doesn't let me pan with the middle mouse button. Like, god damn it, I can't even access their code to like change that. It will not let me change that. Pisses me off, so that's why I use Inkscape. But yeah, that's good and free. Yeah, but I hope that answers your question.
What do you do for 2D stuff? Did you just use
I use vector graphics as well.
2D, like, instead of 3D graphics, 2D graphics?
Yeah, because they're all sprites, right? So you can do 2D in two ways, where you can do pseudo 2D, where you have 3D objects, but you're only just looking at it from one dimension, and you're kind of ignoring everything else, in which case you can use 3D models. Or the classic like sprite-based one, where you just have 2D pictures. I usually use vector just because it's, if I decide like, oh, I want the resolution to be higher or lower, I can just change that on the, very quickly with the SVG and not worry about getting pixelated and stuff. Yeah, you just have sprites moving around. They're just flat planes in Unity space. Anything else? Good? Yeah?
When you're exporting models from Blender, what I noticed is that because of like the
Y-axis up.
Yeah, it's always rotated 90 degrees about X, right?
Exactly.
So what's the ideal format to export Blender models?
It's a really good question. Well, Blender exports in like a shit ton of formats. I know there's like a lot of DAE, there's FBX, there's OBJ, there's I don't know, a ton. For like a variety of different reasons, I actually use like almost all of them because FBX preserves animations, which is nice. FBX also allows you, it has a little option when you export on Blender on like the left side, it'll ask you, do you want us to reorient this with Y-axis up or Z-axis up? And you can tell it that, and then once Unity imports it. What is interesting is Unity will still auto-rotate it 90 degrees, but then once you just un-rotate it, it'll be the correct way up and zero rotation. If that's not an option for you, what actually works really well is just throwing it in an empty game object, orienting it within the empty game object, and orienting that parent object whatever way you want. And that way, like a very good practice is what I do, learning the hard way from that, is that if all these models the wrong way, and I'd be like, all right, I've got my mesh with this, the mesh that I made in the thing, has a rigid body on it, and it's got a collider, and it's got my script on it, but it's all rotated 90 degrees all the time. And sometimes I want to access this transform up because it's very useful for knowing like how to, like which direction to jump in, but its up is always the wrong way. And I'm like, oh crap. A really good practice is to just put the mesh as a child game object to the game object that has all the real functionality. So it's almost like my script, my collider, my rigid body, all those things are on one empty game object with no mesh at all. And the mesh is just a child. That then the mesh I can orient any which way I want separately of the actual game object itself. And that kind of helps you. Plus, if you re-import your mesh, you don't have to like completely lose that thing you made before.
Yeah, that kind of sounds like what OBJ does.
Yeah.
Like, OBJ like kind of puts the model inside of like a wrapper.
Yeah, you always get like an empty one up there, which is kind of annoying sometimes because if you start doing like large hierarchies of objects in Blender, then it'll make an empty parent for each one of the things, and you'll have this ridiculous hierarchy of like 50 things. Like it's annoying. OBJ I do use because it preserves edge tangent normals and vertex normals and stuff, so you can like shade stuff smooth in Blender or flat. But if you do, if you export OBJ or sometimes FBX, those things won't carry over. It's very annoying. So OBJ is good for that. Good question though. Anyone else? These are really good questions. Okay. I wanted to say a few words about optimization. In that, when you start off doing Unity, I really wouldn't worry too much about optimization unless you're, like, I want to build Halo. Then okay, start off by worrying about optimization. But I would pace yourself, and like as you learn, like it's a hard way to learn when you're starting. Like I want to move a ball left and right. Like, do I need to worry about like polygon count and freaking draw calls right now? Like, no, don't worry about it. But as you go along, keep in mind this magic word, object pooling. When you start instantiating a crap ton of objects like bullets or enemies or like whatever, the act of instantiating and destroying things via script is one of the most taxing things on the CPU. So there's a trick which we call object pooling, where at the start, let's say like my gun fires 30 rounds per minute or per second, right? I'm going to start off by making 40 bullets and then turning them all off, deactivating them so that they're not actually alive. And then whenever my gun needs a bullet, I'll activate it, teleport it to where it should be shot from, shoot it. When it hits the enemy, instead of destroying it, I'll just turn it back off and put it back into the pool. And we make a class that contains all the things that you need to pool, so you never really need to instantiate or destroy something unless you really need more than your pool size, which you have. Then you can just add more to the pool. But that way you kind of have a set amount to begin with, and whenever you need it, you just grab one that's not being used. All right. Anything? You? Okay. Well, thanks for having me, guys. I hope you enjoyed it. Hope you learned something. And yeah, Google the shit out of everything. That's really how I learned. And feel free to like hit me up on Facebook or whatever if you have any questions or want to do a game jam or something. Like, I love doing this. I do it in my free time all the time. I just fuck around and make like crazy random shit because I can. And it's like really cool because the lesson to be learned at the end of the day is that when you are making a world, you're God. You can do anything you want. You can make that guy explode. You can make that guy blue. You can make gravity the other way around. You can do anything. And that is what you have to keep in mind, is that it's all up to you. Like, do whatever you want and don't be afraid. Thank you.
Anything but infinite force, apparently.
What?
Anything but infinite force.
Yeah, okay. Except for infinite force, sorry.
Anyways, thank you so much for doing that.
No problem. That was a lot of fun.
That was awesome. How do I do this now? Do you know how to exit out of QuickTime?
What?